All right. There it is. All right. Now this one is the next one, I believe, correct? All right. What is the probability that the cube he selects is blue? Was that one out of 4? I believe. 1 out of 4, 25%. 1 out of 4, 25%. We're going to go through these kind of quickly because you had a chance, you were to finish these up. So make sure checking your answers. If you have a question, ask, please.
Do we have any more tests in this class?
This year?
Yeah.
Wait, really? I thought we were done after statistics. We have like 2 weeks of school.
I've got to give you guys formative and summative points for the rest of the year.
You should just do those little quizzes online. That are like 10 questions. Just do one of them.
All right, for this one, did you guys get 64%? You had to fill in the two-way table. Should have gotten 64% for that one. Next one. Did you get 4%?
I got 5. I got 5.
Both of us were wrong.
I wasn't very good at 5.
Yeah. I got 4. No.
I got 4. 80 over 100.
There's several of these. I bet you guys would have benefited with some two-way tables. Actually, I don't know if you needed a two-way table for this one. Did you just do 5% of 80%? Okay, you're confused.
80 over 100.
All right. An online retailer conducts a random survey of its customers. The survey shows, guys, please be quiet. The survey shows that 80% of the customers receive their purchases within 4 days. So 80% receive within 4 days. 95% of those customers are satisfied. What percent are not satisfied? 5%. Okay. So, what percent of all customers receive their purchases within 4 days? What percent's that? 80%. Yeah. And are not satisfied. Oh, 80% receive it, and 5% of those are not satisfied. 5% of 80%. 5% of those 80%, okay, are the ones they're asking about. 5% of 80%, which is 4%. Yes? 0.04? 4%. Next. Did you get 299 out of 3966, which is 0.753. So 75.3%. Yes? That one wasn't too bad.
I got 0.075.
Did I met?
0.075.
I think I moved the decimal over one spot. Thank you. So that would have been 7.53%. That sounds right. Thank you. Next. All right, this one I'm going to go over quickly. What is the probability that a randomly selected person attending the concert is an adult or has purchased the ticket in advance? All right. So it's like, what if you're on market or 619? Can you see what the row here is asking about the adults? column here is tickets purchased in advance. So as you go to calculate these, I got 148 out of, was the total 250?
Yeah.
Thank you. 250 plus 140?
Yeah.
Oh, that's what I'm probably, I highlighted the total column there. Plus 140 over 250 minus, what did I count twice? The overlap, right? The 100 out of 250. So is it 188 over 250? Now that one is 0.752. I typed it in correctly. Question on that one. That's a classic OR problem. Overlap. Here, do the probability, subtract the overlap. Next one. Should have added 0.5 and 0.48. These would actually be a drop down on the computer. Actual drop down menu. Select the option. And then subtract 0.25 from the sum. Could you guys read that on your papers?
Yes.
What? Was that a what? Like you're confused on this one? Or is it-
No, we're good.
Alright.
That was the what for us.
I don't think this was on yours, but we did it anyway as a class. Alright, that's the probability packet. Now on to the volume packet.
What about the soccer and lacrosse?
What about the soccer?
Ah,
No.
did I not have that on here? Oh, there it is. Thank you. All right. What is the probability that a student plays soccer or is a girl? Now, here's the deal. This one for sure, I would have made a two-way table. All right, and based on the given information, the table will get filled in like this. What is the probability that a student plays soccer or is a girl? Well, plays soccer. Girl. I did 20 out of 50 plus 30 out of 50 minus the 10 that are counted twice. So 20 out of 50 plus 30 out of 50 minus the 10 out of 50 that were counted twice, which is 40 out of 50 or 80%. 0.8 or 80%. Does that make sense?
Yeah.
Don't be afraid. Listen, even if it's we've had this talk before, even if it's a computer test, don't challenge yourself to see how little you can write down. All right. You're going to get a scrap sheet of paper. You're going to get graph paper. Make sure you're writing things down. If it requires a two-way table, please do so. Next. All right, I do not have the volume reference sheet up here. It's not digital, but we'll look through it on the paper. The front of the page, we're not going to pay attention to today. It's got trigonometry on it. It reminds you sine, cosine, tangent, or SOHCAHTOA. All right.
They give that to us.
They give that to you. The thing next to it are called special right triangles. We didn't have time to do that this year, but if you know SOHCAHTOA, those are a part of SOHCAHTOA. So it's Just kind of, you can figure it out, what is what I'm trying to say. On the back, they give you the area of a triangle, the area of a parallelogram, the area and circumference of a circle. Then to the right in the column, we have general prisms. All right, how familiar are we with volume, like prisms, pyramids? Do you know how to name them? If I asked you to draw a square pyramid or a triangular pyramid.
Like a square on the bottom.
Yeah, here's the easy thing. They're named by their bases. All right. So a square pyramid has a square base. All right, and then all the edges go up to that point, right? Square base, triangular base, okay, anything dashed is something you can't see. So that would be called a triangular pyramid.
What's the quadratic formula?
We'll get that in a bit. What about a prism? Well, they're also named by their bases. So a rectangular prism means it has a rectangle base, and then prism means it stays that shape all the way up. All right. So there's your roughly drawn rectangular prism. It has a length, it has a width, and now it also has a height. Length times width times height. Or another way to remember it is the area of the base, capital B. What is the area of a rectangle? Length times width is the area of the base. So sometimes you'll see that the volume formula, instead of L times W times H, you may see L times W is called the area of the base times the height. Okay, stay with me here for a minute. I need you to listen. Do you agree a rectangular prism is a bunch of rectangles stacked up? Okay. A circle prism is a bunch of circles stacked up. It's just not called a circle prism. A circle prism is a cylinder. It has a special name. A triangular prism is a bunch of triangles stacked up. Here's the basis of volume. If you can find the area of the bottom shape, length times width, what if it's a square? S times S squared, right? If you can find the area of the base, all you have to do is multiply that times the height to find out the volume. Because that multiplying is how many of those stacked up it is. All right? Does that make any sense to you?
Do you do that for all of them?
All prisms can do that. So what you'll see for the volume of any general prism, they'll put general prism. Capital B times H. Well, that's we call it generic, okay? That's a generic capital B. Because if it's a rectangle, what's capital B? If it's a square, what's capital B? S times S squared. If it's a triangle, stay with me here. If it's a triangular prism, I guess that's not dash anymore. If it's triangular prism, what's capital B? Good. Remember, area of a triangle? Area of a triangle is 1/2 the base times the height. Look up here. All eyes up here. Careful. Base isn't always bottom. Base has different meanings. What does this capital B mean again? Area of the base, area of the rectangle, area of the square, area of the triangle. What does this base mean? This little b, base. Base of the triangle, the bottom, right? It's the side, any of the three sides in a triangle could be the base. It's the one that the height is perpendicular to. What's the height? Careful, we're talking about the triangle. Isn't that height the height of that triangle? Can you see it now? So you actually have to do this first to get the capital B for this prism. But what if, back to this, capital B times H. What's the H in this problem? It's the height, not of the triangle. It's the height of the, not of the triangle, height of the capital B times H, capital B times H, capital B times H, capital B times the height of the prism, not the triangle. Do you understand that? It's tricky. If you get confused about what does that capital B versus little b mean? Well, capital B times H of the prism, which is technically out there. Height is always altitude height. Okay? Altitude height. Do you know what that is?
No.
Altitude height. What's the altitude of an airplane? How high it is above the ground. Ready? Slide. Here's a slide from when you were in a playhouse. Okay? Playhouse. Slide. If I said, what's the altitude of that slide? What's the height of that slide? You would not say the length of the slide, would you? It's how high it is up off the ground. Altitude. In other words, if you drop something from it, how it falls is the height. It's not like that thing you drop would not go sideways, diagonally down. It would go straight down. If you drop something from an airplane, height, altitude, straight down. Okay? Flying a kite, what's the altitude of a kite? It's not how long the string is. It's how high it is above the ground, right? So do you see how the altitude height of this prism is, if you were to be up here, drop something down, it's how far it would take to hit that base. But Mr. Westfall, the base doesn't go over there. Well, the base is kind of like a plane. It goes on forever. Imagine it going on forever. It's where it would hit that imaginary point that would be on the base if it were extended. Is this making any sense? Okay. Here's what's really annoying and frustrating for me. This is geometry. All right, this is geometry. Bless you. Probability, not geometry. So why make 20-some% of the test probability and only a little bit volume? Like it just shape. When you think of geometry, when you walked in this year, I bet you were thinking we're going to learn a lot about shapes all year. Shapes, right? And then we hit your proofs and probability and all this other stuff. Okay. Then we finally got to SOHCAHTOA and triangles, and it's like, oh, okay, yeah, this is geometry. It's annoying. If they didn't ask me, they don't care what I think. But what I'm trying to say is, this stuff, if we were going to cut out stuff to not cover before the test, this is something that I just showed you in about 20 minutes, and you're like, okay, I can use those formulas now. If they give me a formula, I could probably use it. Okay? Like, let's look at this shape right here. What shape would you, like, if I were to ask you the volume of this, but it's like a pill, it's in context of a pill. What two shapes make up that pill? A what?
A cylinder and sphere.
I see a cylinder for sure. Do you guys see the cylinder? I see a cylinder. And then two half spheres, which make up one whole sphere. And so at this point, I'd be like, well, what is this 3 really trying to tell me? It's the radius of that sphere. And it's also the radius of the cylinder, isn't it? They're sharing that circle on the end. So what's the volume of the cylinder? Well, this is where you should automatically go to your formula sheet on the OSD and say the volume of a cylinder is pi r squared h. Pi times, do I have the R of the cylinder? Yeah, it's what? 3 squared times, what's the H of the cylinder? Oh, careful. What's that 15 pointing to? The whole pill. But I bet you guys are smart enough to figure this out. If the whole thing's 15, what's the cylinder's height, even though it's laying sideways? What do we know about a sphere? If this is the radius, what's that? It's another radius, isn't it?
Oh, 6.
What's that?
6.
This is 3. This is 3. So what's the actual cylinder's height?
6. Oh.
15, take away 3, take away 3, 9.
Oh. Okay.
Do you see it now? Again, this is one of those things I show you, and you're like, oh yeah, I see it now. Most of you, right? You see it now. That's how you find the volume of a cylinder. What about the volume of a sphere? Because we don't need a half sphere. There's 2 halves. Well, I go to my formula sheet. 4/3 pi r cubed. What's the radius of that sphere? It's 3, isn't it? Can you guys picture it going together? Picture a basketball. What's the radius of a basketball? What's very center out? We already have the radius of that sphere, don't we? Do you guys know how to cube things in your calculator?
Yeah.
Caret,
Yes.
3. I would put 4/3 in parentheses. Now listen, we're not going to actually have to type this in right now. It's multiple choice. But if you were to actually have to get an answer, now, remember, we have things in terms of pi, and then we have it with pi typed in. There's 2 different ways to write the answer. If I want in terms of pi, I put parentheses around the 4 divided by 3. Times, watch, 3 caret to the 3rd power. Caret means it's raised to a power. So 36 pi, and that would be in millimeters cubed. And that one would be 81 pi. Bless you. And what would you do with these 2 volumes to find the volume of the whole pill? Just add them, right? Add them. Now, again, that's not what they asked us in the problem. They're saying which statement best explains how to find it. So now you go through. I want you guys to read them on your own and decide which one do you think is the best option. Who got A? Who's still reading? All right, take a minute. All right, who got A? Who got B? C? D? E? That was just a test. All right, it was A. Good job. All right, here's what I'm trying to say. I think with this formula sheet, I think you guys have the tools you need to work through these problems and use the formulas and figure them out. Okay? I don't know that it would take a full multiple day lesson to go through volumes. Are you guys okay with using the formulas?
Yeah.
Okay. Now, just to be honest, some of these are pretty tough. All right? You have to think it through, break it down. All right? Figure it out. So here's the plan for this week. Today I'm going to give you guys the rest of the time. We'll work through some problems. All right? I'll let you guys see what they look like. work together, figure them out. You are going to have some homework since I won't be seeing you for a couple days, all right? You're going to have to finish most of this packet. Now, it's not a punishment. You guys have your OST next week. That's just where we are. I'm going to see 6th period both days, and I don't want you guys to be at a disadvantage. So I'll let you know here in a minute what you're going to have to do. And then Thursday, we're going to do some practice test problems on the state testing site. I want you to see what it looks like. You guys took it on there last year, right?
Yes.
The algebra one?
Yeah.
I just want to remind you like where the resources are, how to type stuff in. For geometry, I want you to see how to drag and drop. There's drag and drop proofs. Good news, any 2-column proof that you get, you're not going to have to like write in all your statements and reasons. It's going to be mostly drag and drop, like, oh, fill in the blank here, fill in the blank here. Kind of nice. We'll walk through that together and just see what the format looks like. We'll do that for a couple days. And then early next week, we'll do last minute OST review and go from there. So right now, don't delay. Get started on these practice problems. We're gonna skip this problem for now. All right. Skip this prism one, but work on this one first.
Small brain.